Okay, so I'm going to do one swoop through chapter 9 and 10 together. So so what I did is I went out and did a search for second moment of area tables. So I was looking for tables, wasn't looking for the complicated, I just wanted to find some triangles. Oh, I didn't look at that one. So I brought up several of these. And of course, some of them look better than others. But there's a lot of resources on this. But what I want to do, this one has some nice colors on his. Hang on, let me this is a good one because he separates them. But actually, and maybe I want to go to the other one. So you can go find a lot of this information in tables. So you'll see this thing, IX, and this table over here. Well, actually, this table looks the best. So I think I want to just focus on a triangle today. And I'm going to look at, okay, now one of the things he doesn't do, he doesn't go through the thing. So his X bar is where the centroid is. I'm going to go ahead and find the centroid. And then what I'm going to do is I'm going to do something that matches what this guy does. He actually has two IXs. And what we'll go through is what is IX and what is IY. But I just want to do IX to match the triangle here. And then I'll come back and do other ones like next time. There's a bunch of them. I don't need to do all of them. But a triangle and a square, maybe I should do the square or rectangle first, but I'm going to do the triangle. So let's go in and let's start here. So I'm just going to do a triangle. I want to make sure I do the same. I want to do the same variables he's using. So I'm going to go in, I'm going to make it like this, and then we're going to investigate whether it leans over later like that. And what we'll find is kind of interesting. But right now, I'm just going to investigate this. I'm going to say, here's my X, here's my Y. Now, you've got a couple of things you can do. You need to find your centroid. So what I'm going to do is I'm going to do this for both. But before I do this, let me go back and look at his thing. I want to make sure B is the base and H is the height, okay? So I want to stick to his because I want to basically follow this all along. Now the other thing is, and we'll look at this in a second. So X bar is equal to the integral, and I'm just going to put X dA over integral of dA. Now, we talked about this before, and that's going to be nothing more than base times height to the third. It's all okay. So then our choice is to find the value of X bar out of here, the integration of this. Likewise, and I'm probably going to move these over to the right, you have this, and integral of dA, and this, of course, we talked about this last time, base times height to the third. Now, if you want to get and I'm going to use that to do the integrations for me. Oops, I wanted to do that. Okay. That's chapter 9. Okay. Because I shut these down earlier. So I'll get down here. Somewhere he has the triangle. He has maybe the next section. Oh, no, there it is. So he's doing this. So this is what he is doing. So he's used the base and he's used the height as well. So instead of doing what he's doing here, I'm going to relate all this back to your cowl. I don't know whether it's 1, 2, or 3. I don't know. But in essence, oh, yes, you're correct. Yes, thank you. Sorry about that. Where did that 3 come from? I don't know. I have no idea where it came from. So since I'm going to be trying to match the one that's in the table, I'm going to basically kind of omit this one and work on that. So really what I want to do is I want to find where's the centroid. Now, it won't take me 5 seconds, so maybe I should go ahead and include this one as well. So here's what I'm going to do. I got to find this equation. Now, you know, it's a straight line, and it's from a certain height here, h, and it goes down to a certain base here. Now, I'm going to be lazy for a moment, and I'm going to go back and just use this, h over b, b minus, okay, y is equal to h. And I think it was b minus x. Now, how would we find that normally? So, yeah, I just copied it. But how would we find this normally? Well, I know that, and so I'm going to go back and check this out. So I know this thing is y is equal to ax plus b, because it's a straight line. That's a straight line. So if that's a straight line, you know, I can pick any 2 spots and find out where I'm at. So if I pick x equal to, now actually, I should make it this way, constant 1 and constant 2. So these are 2 constants. I'm going to try to find them. So if x were equal to 0, I would be existing right here. If that's the case, then y has to equal to h. I got another one that says x is equal to b, which would be this point right here, and that would say y is equal to 0. So I have 2 conditions that I can use to stick in here to find my C1 and C2. So y equals to this one, h equals to, stick this one in here, equals to C2. So I'm pretty much done there. Oops. Okay, so C2 is equal to h. So now I can write this equation this way, 1x plus h. So stick in 0, I get h, and I'm happy, everybody's happy. Now I'm going to stick in b right in, right in here. Sorry about that. But y is going to be 0, so I'm using this lower condition. Y is equal to 0. I'm going to put in C1. I'm going to put b plus h. So you're like, oh, okay, so I can move the h over. C1 is equal to minus h divided by b. So I get my equation. Give me a second. H. I'm going to put this one in front. That's h over b x. Now, at first glance, you may say, hey, wait a minute, that isn't exactly that until you recognize, hang on, h. If I take an h and a b out of there, then I just got an x here and I got a b here. So the first term has to come back to be h. B, this term times this term does come back to be h. There's this term come back here. Well, it's h over b, it's a minus, and it's a minus, and it's an x. So it does. So in fact, that's how you can get that if you feel like you want to do that. In my case, I just went and copied it. So now, if I want to do the integral, here's where he and I agree to disagree. It's not that I'm being disagreeable with him. It's that actually there's an extra step here that can often cause confusion in chapter 10 based upon the way he's decided to do things. So it's kind of like this. So I put in y. I guess I could pick, okay, dx dy for this upper term. Or maybe I'm more comfortable with y, dy dx. Okay, so what are the implications of these two? One implication, so we'll look at the redraw the thing. Here I am. This one says, okay, hang on. This one says you need to set up your x's and sweep this way. In other words, you take your little tiny d areas, which are dx, dy's, you sweep them across that way. Okay, I'm going to redraw this. Okay, so this other one says, this one says, do your dy's first. You take your little d area and you sweep it up that way. Okay, so as you're sweeping it this way, the first thing I notice is the second integral, where I'm doing the y. Okay, think about this. Okay, so I'm sweeping this way. I got to sweep from 0 to h. So this has to go from 0 to h. That's for the dy. Now the dx has to go from 0 to b. Why is that? Because my sweeps have to go all the way from one end all the way to the other end. But the sweeps are going this way here. Now, what is the other limit? Well, the other limit has to do with this equation. Okay, it kind of depends on the way. It kind of depends on the way you want to do it. And I think we've done this. So I'm just kind of repeating myself. So I can take y equal to, oh shoot, I've already forgot. H divided by b, b minus x. Okay, now that's great here. Okay, so on this one, I'm sweeping all the way out. I'm hitting this along the top. That's my end limit there. In each sweep. I'll go from 0 to, okay. I don't know if I have room. Oh, I know. I can zoom in on it. H over b, b minus x. Because that's the y I'm sweeping at. Now over here in x, okay, let me do this. If I go back to the equation that I had before, which was this original equation right down here, we know they're the same. But this time what I want to do is I want to say y minus h equals to minus h over bx. So we'll change signs. And then I'll do this. B over h y, h minus y. I guess that's probably as far as I need to run it. And so I'll take this thing, do a copy, and go back up here, and say drop it about right there. And now, okay, maybe make it smaller a little bit. Okay, so now in my sweeps that are going from left to right here, my first sweep, the integral that's on the inside, I'm being limited by this line right here. So I'm going from 0, every single sweep goes from 0 to, okay, zoom in on it here, b over h, h minus y. Now, what I'm going to do this, wait, let me see if I can, how do I say this? I'll do this using maxima for both of these. And unfortunately, I didn't leave much space, but fortunately I can do this. I will focus on this way. And I think I did this partially last time, but the only reason I'm doing it additionally, okay, I'm going to do this one here. And I'm going to do that one. Oops, what's happening here? My finger came off. Do this one right here. So I'm going to do both of these. And they should equal to be or turn out to be the same thing unless I goofed. And it's very possible I did. So let's go over to Maxima. And it's full screen, so I'll make it smaller than full screen. And see if I can stick this one. I'll do the upper one first. So what I'm going to do is I'm going to do the integral on the inside. I'm going to integrate. The expression I'm going to integrate is y. I'm going to integrate with respect to x. I'm going to go from 0 to, and this was a problem I had the other day, b divided by h times h minus y. See, it actually added the extra parentheses. And I hit integral. It comes up with something. Now, first of all, got to make sure I did that right. But let's do the integral of the outside. Now, the percent means take the previous integral. We're integrating with respect to y. We're doing a definite integral, and that's supposed to be 0 to h. And then we enter it, and we get that bh squared over 6. bh squared over 6. Now we're going to do this the other way. See, the thing is I think, okay, the complication that occurs in chapter 9 because of the way he does it doesn't really show up. But it does show up in chapter 10. And so this is the reason I switched the way we're doing it. Oops. I need to be able to see the equation. So I need to be right here. Okay, so let's go ahead and do this interval. I'm going to do the inside part first. The inside is an expression that says y. The variable of integration is y. The definite integral goes from 0 to, and I have to be very careful here, h divided by b times b minus x. I think I did okay. Okay. And so it shoves it off the screen. So it looks very ugly. Very ugly. It's very nasty. But that's okay. I do it. Now I'm doing the integral of that term. The percent means I take the previous equation, I integrate it with respect to x, and then going from there to b. And I hit okay, and I get the same thing. bh squared over 6. bh squared over 6. So they both are the same thing. So it doesn't matter which way you do the integration. As long as you're careful about making sure you check your sweeping. Now, this is a weird term. Most people don't use this. But when you're integrating, you are sweeping in one direction, and then you're going back and sweeping in the other. So it's like a CRT screen. You know, the old Cato ray tubes had a plate back there with a positive and negative, and it would shoot an electron beam. It was shooting it right at your head, believe it or not. But there was a phosphorus screen there, and what it would do is it would sweep across. I don't remember if it swept this way or if it swept that way, going up. Anyway, it would sweep. And the way it was sweeping is it would change the voltage of these plates. And so it would shoot a beam out. The voltage of these plates would change. It would bend it this way and bend it up. And then it would change the voltage as the sweep happened. And then it would just go back and sit there and do that over and over. That's the way those old screens work. So that's why I have that mentality of integration sweep, is that you're making something look continuous. When you look at that CRT screen, you know, or this, it looks continuous, right? Now, LCDs are different because each of the things can be excited at the same time. But in a CRT screen, if you get a slow motion camera, you'll see the sweep happening. So in fact, maybe that's why I use the verbiage I do, but that's what you're doing. You're doing a sweep. Your inside integral is doing the sweep. This one from left to right. This one bottom to top. You get the same answer. All you're having to do is make sure your limits are put in there the right way. You notice for the y sweep, I made sure I was putting the y here. But if my internal thing is the x, I got to put the x equation in there. And that's the only difference. Sometimes it's easy to do that. And sometimes the equations are nasty. Like if you had an equation that was y is equal to, I'm just making stuff up, 2 x squared plus 3 cosine of 3x. That's not going to be easy to take x and turn it into a function of y. But guess what? You don't have to do these both ways. You can pick the one that's easiest here. So I'm just showing you can do them both ways. You're going to get the same answer. So you don't have to do both of these. But I can tell you, it's going to work the same answer no matter which way you do it. This is easy because I can take this equation and I can back this equation out of it. Sometimes you have an equation that's not so easy to back out of. So rest assured, just do it one way, whichever way you feel comfortable with. So you get that. And so what you get is BH to the third over, and sorry, it was supposed to, okay, I'm goofing up again. BH squared to the sixth over BH over 2, not 3. Sorry about that. So then what you end up with is BH, B, V, H, this, and this, and you get a 3. So you get an H over 3. So in fact, this is what we expect. You know, it looks like that. But guess what happens now? Here's what I can do next. Okay, the area is the same. Watch this. I'm going to take these same equations, and this is the beauty of doing this way. I'm going to slip right over here. I'm going to do something really weird. Okay, what I'm going to do, first I'm going to hit the escape. I'm going to say I want to find x bar. So all I'm doing is replacing the x. I'm not doing vertical this or that. I'm not doing anything like that. I'm just replacing the x. But guess what happens? I can go right back here and go to the first one. I can go in here. Now I've got to replace dot with an x. You have to hold the shift and hit enter. You get a nasty equation. And then, hang on. I'm integrating that nasty equation with respect to y. Notice what I get. And then I'm going to go down and do that in the next equation. Okay. This next one, I've got to get the y out of the inner side of the integral and put the x. Hold the shift, hit enter. And then I go in here and I do hold the shift, hit enter, and get that. B squared h over 6. Okay, that's equal to b squared h over 6. Equals to b squared h over 6. Compare the two, and you'll see something interesting. The b is squared here and here. The h is squared here and here. So if I'm looking for x bar equals to this over the integral of d area, x bar integral d area, I get h bh hb over 2 bh over 2. What I end up with is b over 3. B over 3. So what happens is this is b over 3. This distance. Now what we're going to do is we're going to jump headlong into chapter 10. Let me show you the difficulty in doing the way he says in chapter 10, but I've got to bring up the PDF for chapter 10, and then we can look at it. This is the part that I don't like that he does in chapter 10. Okay, so he starts in, his whole purpose is this right here, to do that integral. Now what he's saying is, and this is something you got to pay attention to, the fact that y sits here, x sits here. So in other words, think of it like this. Okay, let's just look at our triangle, for example. Think of it like this. When I'm looking for x, I'm actually integrating this way. So actually, technically, now don't get too hung up on this, but these are actually tensors. So technically, they should have two x's, an x and x, or maybe a y. But don't get too hung up on that. What is interesting, so you should have that, right? But watch this. This is so funny and hilarious. Okay, he doesn't do it here. Where's this? There is another term that's called xy. Let me see if I can find it. Give me a second. It may be down in the next section. So just hold that thought for a minute where we're talking about his subscripts. And, oh shoot, he goes straight. Wow, where did he? I thought he put that in there. Anyway, there's another term. You may find it somewhere. On the other term, I just don't happen to be able to find it right off. There's another term that they'll talk about that's this. Ixy is equal to the integral xy d area. And that should tell you, okay, wait a minute. There are two subscripts out here. You'll probably find it in the text somewhere. We don't do it that much. And it has two variables here. So that should lead you to conclude that, yeah, maybe this is an XX and a YY, where these are not, or the opposite of those. They are the opposite of those. But don't get hung up on that. That might come up in mechanics and materials, but it will not change how you work any problems. There's nothing to be changed there. It's just notation sake. Here's the thing I don't like that he does. Here's what he does. He starts talking about a horizontal bar that he's sending up and down, or a vertical bar. And based upon the way he does it, he goes in and he finds this for a vertical or horizontal bar, and he uses this. Okay, when he comes back, okay, so now he's got this bar that he's making left and right, and he's going to run this bar up from the top to bottom. In my mindset, what I would do is sweep. If you just get in this idea that you're just going to sweep across here, just so happens, you're going to sweep. Your first integral is going to be from whatever that equation is. And it's going to be, I don't know what, okay, let's just say he's doing y squared. So he's going to basically be doing sweeps in the x and then the y. But he doesn't do that. Notice what he does. He only does one integral. This is not really the way you were taught in calculus. What you were taught is something different. Turns out what you were taught will work all the time. So I'm going to stick to what you were taught, and let's just look at this. Because if I go over and let me just take this last set. Okay, I'm going to take this last set, and here's what I'm going to do. Just do a copy. I'm going to slide down maybe. Put myself right there. And now what I'm doing is I'm not going to find, let me find out from this thing which one we're doing. We're doing IX. I want to do the IX. Okay, so let's go back. We'll do the IX. I'm going to go ahead and put 2 in there just because I'm being obnoxious. If I have X in there, I need to have Y in here. And I need to have Y squared. So put a Y squared. I don't have to have this. So technically, let's see, this, make it a little closer to that. Get rid of this. Oops. Get rid of that. And make that a little closer to this. Okay. We're going to do this. See what happens. Luckily, I got this thing set up so I can run all the way back up to the top. And what I need to do is the first term there is is inside the integral, y squared. So I'll hold the shift, hit enter. It doesn't look terribly ugly. I mean, I guess it could look worse. Shift and enter. Okay, so I get that for the answer. Let me just write that down. BH to the third over 12. BH to the third over 12. Okay, I'm going to integrate it the different way. I'm going to swap my sweeps. Sounds weird. You swap your sweeps. The integral is over y squared. Oops, sorry. Hold the shift, hit enter. And then hold the shift and hit enter again. BH to the third over 12. BH to the third over 12. First of all, if you're careful, it doesn't matter which integral, which way you sweep. Doesn't matter. Get the same answer. Did we get the same answer he had? Okay, where is it? Okay, so here's something you need to pay attention to. Okay, notice there are two different terms. One has, it looks a little pixelated. One is the lower one is an IX. So it is about this location, the lower location. And it's base height to the third over 12. No, wait a minute. Okay. Base height to third over 12. Okay, we're good. We're happy. What's the other one? Well, the other one is something that's totally different, because let's think about this. Okay, I got a little bit of enough time to do that. Okay, so let me redraw the triangle. Okay, wait a minute. I'll try to do a good job of redrawing the triangle. And what I get is the triangle looks kind of like that. So in this one, I have a coordinate system X and Y. Now what he does a lot of times, he'll say, let's use this other coordinate system. Let's put the coordinate system right on the centroid. Now he called it a prime. He called it a prime. X prime and Y prime. Now if you pick any spot, now on this you're looking at Y, right? So let's just focus on the Y. So if I pick a location here and I say this is Y, then this is Y prime, and this is, this is height, right? Height over 3. So this means that Y, okay, height over 3 plus Y prime is equal to Y. So suddenly, everywhere I see a Y, I need to insert this into it. And now I need to change how I'm integrating. So since we've accepted that they're all going to be the same, I'm just going to work with one of them, because this will be enough to work with one of them. So here we go. I'm going to put this down here. And I'm going to say, okay, I'm going to focus in on it. I'm going to say, now I'm interested in finding, okay, it's not going to be the same. I'm interested in, hey, and you know what? I will make it bigger too, so I can monkey with it a little bit better. I'm interested in, prime. Okay, prime. So I want to know the X prime. I want to know what the Y squared is about that axis. So believe it or not, okay, with this one, I have to insert, everywhere I see a Y, I got to insert, so I see a Y right there. I don't see any Y's right there. Let's see if I can make this work right. Okay, so my Y now has to go differently. Okay, let's pay real close attention to this. Okay, let me redraw this, just so I can, the other drawing is too busy. So now my sweeps go from X is, okay, so here's my X prime, here's my Y prime. My sweeps go from minus base, not base, but okay, base over 3 to 2 base over 3. Because this is what's happening. So if I look back here, my sweep goes to base over 3. And if I move out to the right, it's this. So my x limits change. Okay, just bear with me as I replace these. Minus base over 3, 2 base over 3. There's a much easier way to do this, and I'll show you this in a second. And then I got to change this, of course. So I got to shove that over to the right. Okay. And I'm going to say that these are y prime, but now I'm going to stick in here h over 3 plus y prime. But I got to change this, and I got to change that. So what's the bottom? Okay. So again, here I'm sweeping this way. Hit each of these. This is the internal sweepings. Now, it looks like I'm starting at height minus height over 3. And it looks like to me, this equation right here was y is equal to h b minus x. But wait a minute, y is actually h over 3 plus y prime. So therefore, oh, wait a minute though, but x changes as well. Okay, how does x change? Okay, so now, you know what? Instead of actually trying to decipher that, I'm going to decipher it a different way. Okay, so I know this height. Okay, so I know this location right here. This location here, this is minus height over 3. This is plus 2 height over 3. Now, I have a new equation, y prime is equal to ax prime plus b, or constant 1 and constant 2. Believe me, there's a much easier way to do this, and I'm trying to get to it, although it may actually occur in the next period, because I can just pick this up where I was. Okay, so I have two individual locations. Y is equal to 2h over 3 when x is equal to x prime is equal to. So I take this location, look at right here, x would be minus base over 3. Then I got this location right here. This location is x prime is equal to 2 base over 3 when y prime was equal to minus h over 3. Okay, with all this information, I should be able to back out what the constant 1 and constant 2 is. I have two ways of doing it. I'm going to check it against this in a minute. So, if I put in the y prime, I'm going to do this one first. 2h over 3 equals to c1. This would be x prime goes in there, minus b over 3 plus c2. And then I get another equation which says y comes from here, minus h over 3 is equal to c1, and the value of x prime comes in right here, 2 base over 3 plus c2. If you want to, you can form this in a matrix, and you can start seeing why this is not a fun thing. I'll show you a much easier way to do this in a second. C1, C2. So I get minus base over 3. I get 1. And then I get 2 base over 3. And I get 1 is equal to 2 2h over 3 minus h over 3. Hopefully I didn't mess up. Now, this is not going to be fun. This is not fun at all. Trying to think, I don't have a... I know. Let me just see if this thing will solve it. Wait a minute. Wow, I don't know how, I don't know if it's going to work this way. Okay, wait a minute. Where is that thing? I don't know. I may have regretted going down this path. Let's see what it does. Oops, we can't solve this problem. Whatever. Okay. We're going to take the determinant of the bottom and then the determinant of the top. I hate that. So C1 is going to be, 2h over 3 minus h over 3, 1 and 1. Take the determinant. Will it actually do that? Will it take a determinant? Oh, it did. It took a determinant. How about that? Okay, so at least I got that. H. And then the bottom will be the same no matter what. B over 3. 1. 2b over 3. And 1. That'll be the same on each one. So let's see what we got there. Let's hope. Oh, it did a determinant. Wow. Okay. I'm happy now. So then C2 would be, and this will be minus B. I feel obligated to complete the problem this way, but I may complete it next time. Let's see. And then this is 2h over 3 minus h over 3. What you'll find is when I do the problem the other way, you will gladly enjoy the other way much better than this. Let's see. Oh, hey, it did it. That's over minus b. So that would be h over 3. So I end up with an equation that says y prime is equal to, okay, C1, which is h or minus h over b, times x prime plus h over 3. Okay, so that's what I should put in here. And unfortunately, it's pretty ugly looking. I'm just going to go with it because maybe I can complete it in time if I did. I'll look at doing it, the other way. So what I'll do is I'll just copy this, do a Control-C. I'll put it somewhere, drop it, and then shrink it down to the point that it would fit in right here for a limit. And at this point, this is really ugly looking and really not fun. So you will hopefully have an appreciation for the parallel axis theorem when we do talk about it next time. And see, here's the other problem too. The more calculations you do, the more chance you can end up with an error. H divided by 3 plus, I'm going to call it WP for y prime. Okay. And that's supposed to be squared. So what I mean is, you're taking the square of this. That's supposed to be squared. We're integrating that with respect to y prime. And it's a definite integral, and it goes from minus h over 3, and it goes to, my gosh, minus h divided by b times xp, which I'll call this x prime, because I'm going to integrate that using x prime too. Okay, x prime plus h divided by 3. Okay, I think I can go with it. And look at how nasty and ugly that is. The next integral will integrate that equation, variables xp, because you see buried through here is the xp third. So I'm going to integrate that definite integral from minus b over 3 to, 2 times b divided by 3. And so we get b h to the third over 12. Wait a minute. Okay, so what I got is b h to the third over 12. Okay, that's not what I'm supposed to get. What I'm supposed to get is 1 over 36, bh to the 3 over 36. So I've goofed somewhere. Now, let's take a look. I'm going to try to see if it's a way. Oh, wait a minute. Oh man, I did goof. This was supposed to, okay, so let me see if I can fix this. I'm not integrating this whole term because that is the y. What I'm integrating is y prime. So that should be y prime squared. Because if I'm integrating the y, that is still in reference to this coordinate system. The rest is okay. So my error. Okay. Let me go back and fix that. So it's no wonder I actually got the same answer, because I was integrating the same exact thing. So let's do shift enter. And then it still looks pretty ugly. And then shift enter. There you go. bh to the 3 over 36. So I got the right answer. Again, what I was doing, okay, so let me reiterate what I was doing. I put in here y prime plus h over 3. That actually goes from here. That is actually that coordinate system. That is that. And so I need to be integrating with respect to, where that plane passes, going that. I need to do y prime. So still, it's pretty ugly. And so it turns out the x bar, this one is a particularly interesting one because it is about the centroid. And what we'll do is all this nastiness and everything we did, we don't have to do that if we use the parallel axis then. And so what we'll do next time is we'll just come in here and realize what you do is there's a simple quick mapping from these to those and vice versa. Really simple, really quick. You don't have to do all this other stuff to do that. And so I'm hoping that that gives you an appreciation for why you want to do parallel axis thing. Sorry I took too long. You too.